he was also talking about like the thermodynamics of their new stadium. And it was like, I mean, he's a smart guy.
Yeah, you guys would like him. I think you should
think
try
he's
it.
a good guy too.
Yes, I think so too.
Kind of comes through in the coverage of him. So maybe we should all root for the Bills.
Shannon, I'm ashamed we're recording this, but that's exactly what I said after the first episode of that show. I said I'm rooting for the Bills, except when they play the Bears. Yeah.
Well, one of our graduate students, Joe Robertson, is a diehard Bills fan.
Oh, cool.
Oh,
Yeah, go to the bar to watch the Super Bowl kind of.
I love that. Like the Bills bar in Chicago. Whatever
She's
that
probably
is.
going to watch the preseason game today.
That's awesome.
It's Delilah's, right? That's the Bills
Yes,
bar.
that's right.
Yeah.
That is right.
Yeah, that's right.
Yeah.
Nice. Is that some other team's bar? Because I feel like we've talked about that bar before. Or was it because of the Bills?
I think it was
we were
because of the
talking about
Bills.
The Bills?
Yeah, that
Okay.
came up.
Yeah.
That's hilarious.
The things we know.
I know, right?
Yeah, the things we'll talk about.
Yeah.
Hard knocks. Make a transition to somewhere else and birds. But
Well, we've had a lot of guests this summer so far, and so we kind of wanted to get back to our original format just for a few episodes and talk about like focusing on a specific bird. And we thought it'd be a fun thing just because we all have kind of different perspectives and, you know, different backgrounds on where we're coming from, have each of us like pick out a different bird for each episode. And so to kind of kick off this little series or whatever, Shannon was going to start first. And so Shannon, you picked the club-wing manakin. Do you want to tell us why? Because we're so excited now after learning about it.
I picked it for some obvious reasons, what it does, what it looks like. But I also picked it because the woman whose research we're going to talk about, Kim Bostwick, when our son was really little, when Pete was really little, I was telling him, because I always asked him every day, what'd you learn today that you didn't know yesterday? And he said, well, what did you learn today that you didn't know yesterday? In a little snarky thing, because he didn't like that I asked that, although secretly I think he did. But I said, okay, well, I'll tell you what I learned today. And I told him about club-winged Manakin and how the wings work. And I told him who. And then after that, she was in town and for a meeting, and I said, she's gonna be around, and he looked at me and he goes, oh, that is so cool. You know her?
Oh, that's awesome.
I'm like, so that is my only claim to being cool to my own child, is my association with the woman who did this incredible research to show how this bird makes sounds, and not from its syrinx, not from its vocal organs, which I think is another really cool thing about birds to think about, and it's something that's really common in manakins, to make sounds outside of your vocal organs, so outside of the avian vocal organs called the syrinx. So there's a lot of modified feathers in manakins, and it's all because of sexual selection, just like we talked about with birds of paradise. This group of birds is famous for its dancing. I actually think we should do all species of manakins, because when I started looking back at them, I'm like, every single one of them is so cool. Well, that depends on the taxonomy. 40 some odd.
Oh my God.
Because there are things that used to be thought of as manakins and have the name Manakin in them that aren't. So it's complicated. So they're in the part of the tree for songbirds that includes flycatchers, so the non-Aussine songbirds. They're part of that part of the tree of life for these birds. But they are on the extremes of their behaviors. So this is runaway bizarreness. When females prefer males with novelties, you get, relatively speaking, dullish females and relatively elaborate males. And in this case, the males have changed. Their plumages are really spectacular. The way in which they make sounds is, again, spectacular. They display at leks. Sometimes some of the species in this family display where there's many, many, many individuals displaying at the same time, like 4 to 8 individuals dancing. And the thing about these birds is, well, again, the males don't help at the nest, but the males display in these places called leks. And it's the females that are choosing, but there can be one male displaying, several males displaying. Their dances are really elaborate and amazing. And in this case, for the club-winged manakin, this bird makes a perfect harmonic with its wings by using its wings like a violin with a bow going across it. And that's if you look at the wings online, you can see pictures of them. Their wings are gnarled kind of and a bit twisted. And what happens is that there's several feathers in the secondary, so not the primaries or the flight feathers, but if you go to the next set of feathers towards the body from there, there's several of these feathers that are kind of gnarled and twisted and thickened. And one is super thick, and the other ones are kind of twisted a bit. And when the bird displays, it makes its wing flat and puts it behind its back. And when it does that, the tips of the feathers come into close contact with each other. They touch a little bit, and that causes the gnarled ones beyond the flattened ones to go across that, and makes, like a bow going across a violin string. And so it makes this kind of really strange sound that nobody knew if this could only be known with technology. So Kim Bostwick went in the field with her major professor, Rick Prum, who's a professor at Yale University, and she went in with high-speed cameras. And so she took video of this bird doing this unbelievable display, which you can see online now. There's lots of videos of it. And then she broke it down in slow motion, which the high-speed video captured lets her do, to see exactly what's happening at the top of that display when the wings are touching. And so the vibrations make this perfect harmonic, and the feathers vibrate back and forth faster, at least twice as fast as a hummingbird does.
Wow. Oh, wow.
So
I can play that noise, Shannon. I've got it queued up. Do you want me to play it real quick?
Yeah.
Okay.
Yeah, for sure.
Is it coming through?
It
Yeah.
is.
Oh.
Yeah, no,
Yeah,
it is.
it
Oh,
is.
it was? Okay.
Yeah, it sounds like a machine.
And you really have to see it in conjunction with the physical way in which it has the wings, which looks kind of otherworldly, what it can do with its wings. So it can make 14 different sounds a second.
Oh, wow.
Oh, wow.
Or actually, no, it makes 14 different sounds because of the 7 feathers that are involved with each touch. And it makes 100 touches a second. So it's making, 1,400 sounds all at once that come through as this kind of harmonic that you hear. It's really, birds are amazing.
So that noise, it sounds so like fast. If you were to break it down, it's actually a bunch of like different little noises.
That's right. Yeah.
Oh, cool. That's wild.
Now, can we hear, like humans, can they hear all of those different sounds, or is that a case where the birds just hear it?
So that's a really great question, because I think it's one of the places where technology still needs to catch up. In other words, what your question is basically, what's the female perception of that sound? So for instance, is the selection been for richer sound, for instance, would be the hypothesis. And we just don't know most of the time what females are actually interpreting in that way, although it makes sense that it would be actually that complexity as a way of potentially choosing a mate.
Yeah, we always interpret senses of other organisms through our own, not realizing that we're sometimes not very good. We don't sense things that other organisms sense. So it's hard to know. You'd have to alter the wing in some way to see if that changed what a female responded to. But we certainly can't ask the female bird, hey, what are you listening to? What do you hear? So we can only use these indirect tools to kind of know. I mean, if we broke the wings, my guess is if you fractured the wing feathers or pluck them out, which you could do, that bird would no longer be seen as a club-winged manakin by other club-winged manakins because it couldn't make the sound.
Mm-hmm.
So, that the wing bones in that bird are solid instead of the light ones that you think of for flight in most birds. Those ones are solid because that's the only way it could withstand the pressure of the way in which it moves its wings and vibrates them.
Oh,
That
wow.
it's not just that the feathers are bizarre, the bones themselves, when you see them, are thickened and hard, not soft and kind of air-like. The inside of bird bones usually are. So everything
actually,
about this bird is cool.
That's an interesting point. So the only place this bird is found is in the western forests west of the Andes in Colombia and into northern Ecuador. So it's found in what's called the Choco region of South America, which gets some of the heaviest rainfall of anywhere, and it's a bird that's up in the foothills kind of the Andes. And what I was thinking about this is, another way you could potentially look at it is, are there any variations in male vocalizations that you can detect? Because then you might be able to attribute that. And with other manakins, they've done some really neat stuff associated with trying to figure out like who alpha males are. But these clubwing manakins are different because they're actually they're not lekking in the sense of some of the other species where there are a bunch of males in a given area that are all displaying. They're more solitary, and so it's a lot harder to figure out exactly what's going on. So for instance, Kim had to go into collections and I think do x-rays on super old specimens of this bird because it's not particularly common in collections.
Yeah. We only have 3. That's all.
Oh, wow.
We have 150 mannequins in our collection, but we only have 3 of this particular.
When you say 150
no,
mannequins,
we have 150 Macaropterus, which is the genus name for clubwing manakin. We have 150, but only 3 of this one, which has a very fun scientific name. Macaropterus, we can talk about what that means, but the species name is deliciosus, which is I like. So
that's because it's good to eat.
I was going to say, what does that mean?
Yeah. How did it get that
Tasty.
name?
It means delightful, pleasurable, delicate, delectable, not just good to eat.
It's about
Okay.
that long, so it would just be a
Yeah,
little.
I don't think you're getting
Just a
much
taste.
much out of that. So, like all mannequins, it's pretty small, has a big head, and I guess Macaropterus means knife, dagger, and wing. So Macara means knife or dagger, and Pteros means winged. So appropriately named. There are 5 species in the genus, including one that was just described in. This is an interesting story. It was just described in 2017, based solely on vocalizations. So it's not distinguishable at all from other things in the species it used to be part of, but it's distinguished based on vocalizations, which is always a controversial aspect of bird taxonomy.
Well, in my bias towards distributions, I would say it's also geographically distinct.
Yeah,
Oh, okay.
fair. So you have to hear it and or know where you are to know what you're
Okay.
to know what it is, what you're seeing, because you
But-
can't, by your own eye or even by measuring, it seems, you can't distinguish them from the things. You have to hear it.
And these other members are geographic replacements that look a lot like clubwing manakin on the east side of the Andes. There several of these species are, and yet they don't do the same thing in terms of what clubwing manakins do, and they don't have the super modifications that Shannon's been describing.
And
Are
they're
there
absolutely
other-
adorable.
Cool.
When you go look at them, and they have really cool names: striolated, painted, kinglet, fiery capped. So
Cool.
lots of mannequins have cool names.
Are there other birds that make noises like with their feathers in this way? Is that like it's just the mannequin does it in such like a heightened way or in a fast way that it's so unique? Or
Nothing makes, I don't think any vertebrate makes sounds this way. No other birds make sounds this way. Other birds use feathers to make sounds, but not like this.
Okay.
So, it's reminiscent of some insect stridulations or whatever that word is, but nothing else makes sounds this way, which is why describing it must have been so exciting for Kim to finally figure it out exactly what is going on. Obviously people have been looking at this bird for hundreds of years, and she was the one who figured it out, what it was doing. And she wrote this. We'll have to link to it. I'm not sure you can get it in the normal web, but you can get it in the Wayback Web. She wrote an article about this that was at Cornell. She used to be the collections manager of birds and mammals at Cornell, and it's called From Feathers, a Violin, which I think is a really, I really like that. It's kind of reminiscent of Dust in the Wind, which is, I imagine, even though those words are not in Dust in the Wind, I imagine that was a reference for her. Anyways.
That's very cool. How does the bone structure affect their flight?
Really good question. I mean, so on the one level, it can't affect it too much, or there won't be, they won't be able to forage effectively. Makes you wonder sometimes. I mean, they're such small birds, and they have little rounded wings, and so one of the reasons why the species are likely to be geographically separated the way they are is they probably don't disperse very well. Although again, we don't have much real data on any of that. But those would be, so they can fly around enough to get their food for sure. And those are the kinds of trade-offs that have to be taken account for in the evolutionary history of those birds as they try to evolve sounds like that, which is probably why it's not very common.
Yeah. Wow.
There must be a lot of pressure. I was just going to say there must be a lot of pressure in order, like, that they need solid bones in order to do this. Like, how much pressure are they putting on their feathers to make that noise? Like, that's got to be a lot, right?
I mean,
yeah.
I think the pressure is, at some level is really on the wings when it comes right down to it. And that's led to the over-evolution time to that thickening.
I mean, think about it. It's got the equivalent of penguin wings in terms of how just outside the distribution of normal wings they are. And we all know that penguins do really weird things. Ostriches, the birds that are flightless, their bones solidify basically too and are very, very dense. But this one is not just solid, it's kind of, the shape has changed and everything to accomplish that. So hummingbirds accomplish that by making their breast muscles ginormous. Okay. So the keel on the breastbone on the keel on the bird of a hummingbird is huge to get them to withstand the amount of muscle mass that is needed to be able to hover like that. So this bird accomplishes it differently.
But Amanda, coming back to your point, this is a bird that I would predict will never show up on Hawaii.
Okay.
In other words, even on the west coast of South America, that distribution is likely to stay really small.
Okay.
Just because, although actually, when I was looking at this, I was surprised to realize that it does appear to be actually expanding southward into Ecuador in the last 30, 40 years.
Oh, interesting. Do you think it's climate change or like
that's a really interesting. It's an interesting question. I mean, that area is a bizarre transition. Southern part of the Choco gives way to actually a region that's super dry in northwestern Peru. And I don't know. It may be getting wet in some of those areas there.
Oh, okay.
Their distribution looked like it's just such a tiny little sliver. Like when I looked it up, I always love when we cover these birds where you're like, wait, that's the only place where they are. Like that's you look crazy. At and where, so is it in Ecuador or where exactly are they again?
So it's the Choco forests of Western Colombia for the most part, and then it extends into Ecuador a little bit.
Okay.
And again, I'm getting ready to teach biogeography this quarter at the University of Chicago, and there's an area that is called an area of endemism because there are other birds that have their entire distributions basically in that same little area of super wet forest, and other animals too. It's a really interesting hot spot that's pretty difficult to get to, not always all that safe to get to. And so it's a really important habitat. And you can imagine that as human populations expand, those areas become really potentially endangered very quickly. And the only thing that's really saving that area is that with that amount of rainfall, it's been a hard place for humans to colonize through the years.
Is that habitat
Thank
called a
God.
cloud forest? When I was researching, I saw it called a cloud forest, and I was like, what a cool name. But is that...
Yeah.
I'm
So
a
technically,
Midwesterner
that's-
from Illinois, so I'm not familiar with and not a scientist.
Right.
But when I saw cloud forest, I was like, this sounds cool.
Yeah, well, you guys, when you get to Costa Rica and you get up into the so a lot of the cloud forests for the most part are upper elevation, and
Okay.
Okay.
and so they're where the water gets trapped along the sides of these tall mountains. But there can
okay.
be really wet forests. So, for instance, the Olympic Peninsula is considered to be a really wet forest in a temperate area, and the Choco is like that in South America. So it's a super wet tropical forest, but it also extends up into the foothills, and so this bird is actually in the foothills of that area.
Okay.
So it probably does get up into places that would be borderline cloud forest.
Oh, okay.
Very cool.
I got you. And I had a question too about just the specimen. So can you, like, with your eye, like, see the feathers and like be able to tell?
Oh, yeah.
Yeah. So when you look at them,
Yeah.
you can
I meant
totally
to take
tell
a
how
picture
different.
last week, and yeah. I'll
Cool.
take some pictures of the specimen, one of the specimens that we have, and we can put them up when we post this episode. But yeah, they're
That's-
obviously just gnarled and weird looking.
But
Cool.
but one of the things about the way we traditionally prepare specimens made this characteristic harder to look at than you might want, in the sense that it's really great to see a spread wing, but most study skins have the wings folded and close to the body.
Right.
And so that was
Oh.
another thing that Kim was dealing with a little bit as she first started delving into this, was how do you get at the characteristics that you most want to see really well?
I was
Yeah,
wondering,
because
with-
you'd break the wing if you tried, right? If
Okay.
you tried to flatten it out, you would break the wing on the specimen. And we don't have very many spread wings, and we certainly don't prepare birds on average with one wing open. Those points are very vulnerable to breaking, so we'd have even more broken birds than you can get normally, and they take up way too much space.
These
Oh.
mannequins are
Totally.
pretty small, though.
They are, but it would be nice to have spread wings of everything. I think
Yeah.
that would be a really great thing.
Shannon, you read my mind because I was going to ask, is it inside a specimen? Is it really just bones and then it's skin on the outside? There's no, like, all the connective tissue and everything is removed.
Yeah, in a specimen, we take off
Yeah.
everything that could rot. So,
Okay.
So there are bones, and how people prepare them leave different pieces of bones in. So there's usually part of the skull, the wing bones, the leg bones are still there, but the meat has been removed. The internal organs have been removed. The brain is removed. Eyes are removed. All of that is replaced with cotton. So that's why you see the white-eyed birds. They're, not really white eyes, but
Okay.
yeah, otherwise they would just rot. And it doesn't
Okay.
take long for a bird to rot. The good part is that the skin is fairly thin and they dry really quickly before they rot. As long as you take off, most of the meat, they'll dry first. And then you keep bugs away from them, because moths
Oh.
and other beetles and stuff find them very tasty.
Okay. We eat the skin and whatever.
Yeah, they'll leave
Yeah.
you dust. You will open the
Ugh.
drawers and you will see on the white pieces of the white paper you have down to protect the birds, you will see an outline of the bird in dust,
Oh my
feather dust. That's
gosh.
it.
That's
Oh
crazy.
my gosh.
Like there's no other pieces of it. They're all
That
all
is
gone.
crazy.
All the bones, the thread. I mean, it's all gone.
Amazing.
Tag
I was
gone.
Yeah. That's crazy. There's when RJ and I I'm trying to think. Was it the day we met John when we did the tour of the specimen room?
Mhm.
RJ, do you remember this? When
Yeah.
with the beetles? Yeah. Was that the day we met John?
Oh. Yeah, it was.
Yeah, okay. So
Talking about
on the
beetles
same
that you... Right.
Yes.
Yeah.
That's what I was
So-
going to say, because you guys use those. I mean, you use a special kind of beetle for that purpose, right?
Yes,
Yeah.
and so there's a whole nother way we could prepare specimens, and that's one thing that, again, coming back to Kim, when she was trying to do this, I don't think there was a single specimen that had been prepared as a skeleton of club-winged manakin. And that's in part because people just didn't realize how absolutely cool it was. And there just aren't that many specimens. And so everybody had thought, well, the best thing to do is prepare a skin. And, again, technology being what it is, one of the amazing things is in certain situations like this, we can now go back to old specimens and use them or image them in ways that allow us to look at what was left by the original preparators, even back in the 1890s, to answer really good questions. And as a matter of fact, this came up actually on Friday with a Cuban paleontologist we have as a postdoc at the Field Museum, who was asking us about a fossil that they've found from the Dominican Republic of a bird of prey, and that they think is an accipiter as opposed to a buteo, so more like a Cooper's hawk than like a red-tailed hawk. But they have, but the bones actually are showing traits that are intermediate. Well, they're endemic members of the genus Accipiter in Cuba. There's this thing called Accipiter gundlachii. We have 3 specimens of it, but they're all skins. So what we're going to do is we're going to CT scan one of those skeletons, because we'll be able to see the humerus and the tarsometatarsus, the leg bones, in that CT scan in a way that'll allow the paleontologist to actually use the traits of that quote unquote modern bird to look at how it compares to the fossil that he's got that he wants to look at. So it's just
cool.
it's even when we've done things in some senses, I mean, the reason they were prepared as skins is because we were using the feathers to do most of the taxonomic work that people were doing at the time. And so that's why they were prepared as skins. But they still left some material inside. And, another example is when Shannon and Chad Eliason were doing work on kingfisher skulls. One of the coolest kingfishers is shovel-billed kingfisher, but there wasn't a skeleton anywhere in the world of it to do CT scanning of the skull. So Chad got a skin of ours CT scanned, and most of the skull was there, and he was able to get the data on both the bill and the brain case from that specimen.
Awesome. So it had enough bone to do the trick for him.
Yep.
Yeah. Very
cool. And it'll be this.
It would be hard to imagine tearing the feathers off of a club-winged manakin to make a skeleton. I mean, nobody is. I mean, I understand why we should do that, so that there's a skeleton for scientific study. But the idea of pulling those unbelievably bizarre, unique, cool feathers off, putting them in the trash I get it. Bird people are too attached to feathers.
Yeah.
But at the same time, I mean, some of these noises are made by feathers.
Oh, yeah.
Yeah.
So one of the ones that I didn't know about was we had Marky Muchler on talking about limpkins a while ago, and it turns out limpkins have modified wing feathers that apparently make a sound.
Oh,
very cool.
Huh.
Jeez. Do museums have? We always talk about how technology is changing everything. Do they have like CT scanners? Like, so from now on, you can CT scan a bird and then have that digital image to disseminate and share?
Yeah, go ahead, Shannon.
Well, the answer is until recently, no. I mean, we have machines now, but we didn't. So often we've used machines that other institutions have set up, these scanning facilities. But it isn't routine for us to scan things yet. We would need more staff to do that. We don't have enough staff to maintain the collections the way we would like to, and to do some of the digital things we'd like to. It would be great to have CT scans of everything, make them available so that people who get an idea can get some data quickly from our specimens, because that's a really good use of specimens for people, is to have them CT scanned and that all of those data available. But we don't, so that gets done piecemeal. So if you're doing a project, you'll do it, and then those data will get attached to the specimen record, so that you have all of these accessory pieces of data, what John would call the extended specimen. All of these things are part of part of that concept.
Yeah,
But we don't routinely do that.
Well,
Okay.
except that we did have an NSF grant that we were part of, where we were CT scanning as many fluid specimens as we could, and those scans provide wonderful imagery of the articulated skeleton in ways that sometimes can be really useful, because those articulations go away when you throw them into the domestic beetle colony and make a regular skeleton out of it. And yeah, I mean, in addition to the staffing challenge, you've got challenges associated with managing all the data, and you've got to provide the service contracts to maintain the machines. And
Right.
so we're embarking on some of those things, and I think that it really highlights how right now is an amazing time in terms of scientific research, and obviously some of the funding issues associated with what's going on in the federal government are really substantial in terms of curtailing some of the possibilities associated with it.
Yeah. I'm about to work with some colleagues at the University of Alberta to get research on kingfisher tau proteins moving forward, because I don't know how to fund that in the United States anymore.
Yeah.
The way funding is working, there will be political appointees who will decide whether or not what you're doing should be funded, and only if it's consistent with the president's scientific goals. And that leaves most of what we do out of funding. So, you have to find a way to get things done. And unfortunately, these days, a lot of that will not be done in collaboration with American funding institutions, which lessens the power of any findings to benefit people in the United States. So much innovation has come from the funding of basic research. And
Gosh,
the idea that these things are lost it makes me sick too. So, if you think your vote doesn't matter, it does. It matters a lot.
Well, and
until you're
supporting
gerrymandered.
Right. Yeah. Everybody needs science. Yeah.
I mean, the freedom that people in the United States scientists have had to do science there's nowhere else in the world where people have had this kind of freedom. And the benefits to humanity that have come from research, basic science that's been done in universities or museums like the Field Museum, is you can't even measure the consequences of that. They're so vast. They touch everything. Every bit of human health development that you think of, that comes from university research. The artificial intelligence tools that people are using come out of universities. The drug development aspects come out of universities. These are not, corporations do not invent these things. They monetize them, they develop them, they turn them into things that can help people, the end bit of it, but they're not funding the basic research that goes into these things. The people of the United States are funding that.
Well, and coming back to just the visualization tools is, we've talked about that they're expensive to maintain. There's data and people, and yet at the same time, all four of the research sections at the Field Museum, so anthropology, geology, life sciences, including zoology and botany, have researchers that are actually using the CT scanners in the museum now to get data in ways that they never dreamed of previously. So
That's awesome.
we'll see what happens.
Yeah.
We're not going to stop studying things. Fair warning, the Earth is not going to stop changing just because some people have decided that climate change isn't real and doesn't have to be funded. So I can just tell you, we're not stopping. We're not stopping.
Awesome.
And we're not stopping educating the next generation of people either, who will go and follow after us.
Yeah.
It was so much fun at the barbecue when we were at your place few weeks ago, John and Shannon, just to see like all of your, everybody that is studying under you. And like, I mean, you have such a awesome community of people that you work with that you're passing everything on to, and that are just as passionate as you two. I mean, that was just a lot of fun. I just wanted to point that out.
Well, if you want to be hopeful about the world, go spend time with some 20-year-olds, because old people just need to help young people and get out of the way. And I say that, I mean that for real, No,
I would say they need to support what those young people.
That's what I mean. Help them, and then get out of the way. Let them move things forward.
Yeah.
Because being around people who are that dynamic and creative is fun. That's where the hope comes from. Spend time with people who are younger than you. And younger people spend time with people who have a lot of experience too. It takes a lot of different approaches to make things function, make things work, make things advance. And we are really lucky that we have smart, committed, caring people that are around us. John and I have one rule if you want to be around us, which is, well, are we allowed to swear? Don't be an asshole. That's the rule.
That's a good rule.
It's a good rule. So we do have a mailbag question that kind of. Oh, sorry. See, we do have a mailbag question.
I don't mean you particular. I mean, that's just a general rule. Be
RJ,
nice.
come on.
I'm being an asshole with my mailbag question.
No, you're not.
No, I'm kidding. No, I wanted to say that one of our mailbag questions kind of ties into what we were talking about, so I thought it might be a good segue to get into. Do we want to get into this, or should we? Is there anything else on the Club Wing Manakin?
What did you guys think when you? Did you guys have any idea that bird existed or anything about it before I told you what I chose? So what did you feel when you went and looked at the videos or started reading about it?
Oh, we were so excited. Do you want to start? Like, yeah, sure. Yeah, we were just so excited. I feel like there's so many times where both of you, John and Shannon, have told us about a bird that we had no idea existed, and we look it up and it just blows our mind because there's some little thing about it that's unique, whether it's like, the oil birds with their echolocation. I feel like these things, they make sounds like the way an insect does. It's like there's, I don't know, anytime there's a bird where you're like, this is the only thing that does it this way, but there's other I don't know. It just felt so unique, like learning about how it did that with its feathers. And it just made us want to learn more about like other birds too. Because every time you find out about something crazy like this, it's like peeling back layers of the onion where you're like, wait, what else is out there? What else behaves in these completely bizarre, unique ways that it's adapted? I don't know. That's kind of how I felt. Amanda?
Yeah. I was just say, beautifully said. I think my big impression when we were watching videos of this bird was how much like a robot or a machine it sounded like. Like, it did not sound like something in nature. And I was like, leave it to nature to like out-robot a robot. I thought it was so cool. Yeah, I just thought it was so cool. Yeah.
All right, so our question then, so this is from Chris, and Chris says, hello all, I hope this message finds you well. My name is Chris, and I am currently living in Illinois. I recently finished my bachelor's in biology and hope to go for my master's. I was actually recommended this podcast by Anderson, and I might butcher this last name, Fajo.
Excellent.
Good job.
Okay, thanks. Anderson Fajo. Shannon and John will be happy to know their coworkers are plugging the podcast after a seminar when I mentioned I was interested in birds. My question is, if anyone has some tips or words of wisdom for new and current college students about how to navigate the changing scientific landscape with grants and all that being cut, or just in general. Also, I think an interesting episode would be in regards to the hairy and downy woodpeckers because of how closely they resemble each other in appearance, diet, range, and calls. Thank you, Chris.
So we should post a paper that was done by Jacob Cooper when he was a graduate student here on mimicry in hairy and downy woodpeckers.
Oh, cool.
And so there's been some work done on that. I think there's more work that could be done. And then as a segue into this question. I mean, we get a lot of emails from people that are interested in trying to go into graduate school. And coming back to something Shannon said earlier, at some level, my intention is not to let any of what's going on nationally in terms of funding changes the ability for somebody who really wants to go to graduate school to make the case for themselves. And so when somebody contacts us, what we often do is we'll meet with them either in the museum or via Zoom and just talk about the kinds of things that will help make them marketable in a sense, trying to get field experience, just, getting to know the kind of people that are doing research that you might be interested in doing and contacting them. Because, you always have to have thick skin in this because people are busy. And sometimes, I'm brutally capable of missing an email and not getting back to somebody. But that doesn't mean I am not willing to potentially talk to them down the road. And so you have to have kind of thick skin about it. But, you want to get to know who's out there doing things that you might be interested in doing. And then the other thing we always tell people is, you talk to the graduate students of those people too, because you may find out good and bad things that make a difference in terms of where you might want to apply.
John's being more practical than me. I think you should do things you love, because when things are hard, like things are right now for science, it's a lot better if you really like what you do and you like who you do it with. And that can make you get through a lot of terrible situations. The other thing is you have to vote with your values. So this is a young person who is of voting age right now. So you have agency to make it different. You want your life to be different. You want your world to be different. You want it to be better for your kids, better for your parents and grandparents, better in general. Vote with those values. Because that's the only way it's going to change in the United States. There's no savior that's going to come down and wave their magic wand and make our world better. The cynicism is huge. The ineffectiveness of politicians basically to meet the moment is profound. So, so don't wait for a savior. If this is something you want to do, be bold. Be brave, introduce yourself to people, and get help, because there's lots of people that'll help, and if John doesn't answer you, you should send me an email, because my email inbox gets really full of messages from people who are looking for him. And I'm a lot better at not ignoring emails.
Well, I'm going to change the topic real quickly and just emphasize that I'm going to get super political here. Had the Democrats won the last election, it's very possible that NSF would have been looking at an increase in funding that would have made the funding at NSF comparable to what NIH gets.
Oh, wow.
And that was literally recommended by the Office of Science and Technology of the president while Joe Biden was president. And I think Kamala Harris would have supported that. So where I'm going with this is coming back to what Shannon said. People should vote. And if you care about science, I think there's some pretty clear patterns with respect to who supports what these days.
And I think voting all the way up and down, it matters a lot, because one of the things that has to happen, and this takes generations, is banning books is bad. So we have to change what people are learning, how they're learning to think. Artificial intelligence isn't going to think for people in the same way. So give you access to information, and it might put it together in interesting ways. But the people who are going to win that race are the ones who can integrate across information, who can think, who can understand, reason, make leaps that are interesting. And that requires, broad education, including the things you don't agree with. That's what it is to be human, is to go and learn these things. You can't be protected from life by hiding books. And you can't protect your kids from life by hiding books from them either, because they'll do what I did as a little kid, which is that they'll get the books and they'll sit under their covers with a flashlight and they'll read when you're not there. Yeah. I was absolutely incorrigible about that. There's nothing my mom tried to make me go to sleep. I just wasn't going to do it. And I think that's true of most kids, is that when they want to learn something, they're going to go learn it. So make sure they have the right tools to learn the right information. There are real facts in this world. And if they're inconvenient with other beliefs, okay, you got to figure out how you're going to think about that and what you're going to do. But denying the results of good scientific experiments is lunacy. Cutting back the use of the development of mRNA vaccines, which is what the U.S. is doing right now, that's insane. You know, there are childhood cancers that can be cured with these that we're just in the beginning stages of that. Do you want to deny a kid that has glioblastoma the chance to actually have that cancer be taken completely out of their bodies?
The chance to become an ornithologist.
I mean, I don't, that's just not moral to me.
No.
Or ethical. And the only way to not be so duped by science or by people who have illegitimate goals is to understand how things work. And that requires education. So that means you've got to vote for your values when it comes to whoever's on the school board in your local district. Who's going to be mayor? Who's going to decide how resources are used in your local district? How are you going to fund schools? There's lots of things that need to change, and they can only change if people vote. That's why I became a U.S. citizen, believe it or not, is because I felt like the only real thing I could have a say in is voting. So, yeah, people who are born in this country are super lucky to be born here and to have the advantages of living in this country. So squandering it on political nonsense that divides people, that is unkind and cruel. We would never want our kids to be raised that way, right? So why are we putting up with that from politicians? They're doing that in our name, separating families, putting people in horrible prisons. Have you ever been to southern Florida at this time of year? That is a torturous thing. You know?
No, but there are a lot of good birds down there. And so, if Chris finds a good graduate program down in Florida, and there's some very, very good ones, he could take advantage of it.
Yeah. Chris should come and talk to us. We're happy to talk to him about what he wants to do.
But as I was thinking about this, I was also thinking he doesn't have to listen to us. It doesn't mean we're necessarily right about things.
Yeah, but that's the fun thing about being around other people, is when they tell you things and you realize that you weren't thinking about it holistically enough. And you get to change your mind, because that's what advanced evidence should do, help you change your mind.
That's a good question.
Yeah. That was great. Well said.
See, people like Chris can change the world, right? And he's got a long life ahead of him, so he can make a big impact.
Yeah, thanks, Chris. Thanks for the question. And I think we're getting close on time. Shannon, do you want to wrap it up on the clubwing manakin? It's your bird.
You never know.
Yeah.
You never know what you're going to find. You never know what treats the evolutionary process has generated for you to go and understand and take a look at.
Love that. All right.